All right, this is our topic 4 on bonding. So we've talked a little bit about what forming compounds is or what a compound is in general. Maybe in like the first lesson, if we can think back to that. A compound is two or more elements that are bonded together. Okay, so when we're talking about forming compounds, we'll keep that in mind of what really a compound is. So it says when two atoms collide, their valence electrons interact, and a chemical bond forms between the atoms if the arrangement of electrons increases the stability of each atom. This completes a lone pair or results in a full orbital. And what they mean by orbital there is like that valence shell. I don't know why they would use a different word. So this really means the valence shell. Okay, that outer shell. Okay. So it says metallic atoms tend to give up electrons to other atoms, forming cations. Non-metallic atoms tend to accept electrons from other atoms, forming anions. So we've already talked about what an anion and a cation is, but just to remind you, the cations are positive and anions are negative. And when it's saying a metallic, so those are typically metals. So metals will become positive or cations. And non-metals, or those gases on that right-hand side of the periodic table, they would become anions or negatives. Non-metallic atoms may also share electrons with other non-metallic atoms. So these are molecular compounds. And these things, they share electrons, which is really important. They don't steal them. These non-metallic or molecular compounds are sharing electrons. So let's see a little bit more about what the difference is between an ionic or a molecular compound. So in ionic compounds, they form between metals and nonmetals. And typically, like I said, the metals are normally a positively charged thing, and metals are typically, or nonmetals are typically negatively charged. The electrons are transferred from metal to nonmetal, so they're not just sharing them, but this sodium in this example is actually giving chlorine that electron. And when it gives it an electron, then it can become happy. Remember, they want to be like the cool kids, the noble gases. Well, once this guy gets that extra electron, now he's got 8, and chlorine is now happy or stable. And when sodium loses one, it becomes like the noble gases as well. Just let me go back to the periodic table so I can show you that. So sodium is right here. When it loses one electron, it'll become just like this guy, so neon. So it loses that extra one in its valence shell, so now its valence shell is full. Chlorine gains that, so it moves over to here to be like argon, and now it's full as well. So sodium and chloride together, great pair, because they make each other complete or like a noble gas. Where on the other hand, by themselves, they are, I guess, unstable and they're better bonded together. All right. Now the molecular ones, on the other hand, those are two nonmetals, and molecular compounds, they share their electrons, so they don't give them away, but they share them so that they become complete with that sharing. So hydrogen would only have one, and oxygen would have 6. So these two hydrogens share their electron to make oxygen have 8, and then the hydrogens have 2, so they're happy as well. And something to note here is that the sharing, this doesn't create as strong of a bond. So I'm going to say it's a weaker bond, where an ionic is a pretty strong bond. They don't have to share anything, they're giving it away, and giving that creates that strong opposites attract bond. So this practice question says determine whether each of the following compounds are ionic or molecular. So I'm going to do one thing, just take a screenshot of this. And then we can stay on this document. All right, so the first one is carbon dioxide. So I'm going to look at this periodic table at the same time and go back and forth like this. So carbon dioxide, we were trying to figure out if it's ionic or molecular. Well, the first thing we got to note here is that ionic means it is a metal and a non-metal. And if you want, you can write this on your periodic table. I'm okay with that. So ionic, metal, and non-metal. All right. Where molecular, on the other hand, is two nonmetals. All right. So if we're looking at CO2, we first have to really just look, is there a metal there? So we got carbon and oxygen. So if we go to our periodic table and we look for carbon and oxygen, sorry, I took a picture of it when it has those circles on it. But carbon is right here, and oxygen is number 8. And they're both in that green, light green area. And if we look at light green on here, that's non-metals. So there's no metal in that compound, which means that it must be molecular. And I don't want to write with a highlighter. All right. The next one is CuCl2. So we got to look, whenever it's an ionic, it's always going to have the metal at the first. So we look to see what the heck is Cu. And it might take you a little while because you're not used to the periodic table to find it, but I'm going to zero in on it for you. It's number 29, and it's copper. It's in the red color. It's a transition metal. So the key word there is a metal. So whenever you see a metal, you know ionic. Metals will only exist if it's an ionic compound. Sodium oxide, again, we got to look for what is sodium. Is that a metal or a non-metal? Sodium is, I don't know why I can't zero in on it. It's the one that's right here, number 11, the one I have circled on the very left-hand side. That's orange. Orange is an alkali metal. So we know that sodium oxide would be a ionic. The heck. The next one is FeNO3. So again, your major goal, look up the very first element there, Fe. You might remember that one from the other day. and this might take you a little while, but for me, I remember where they are. Fe is iron. It's a transition metal, which means that, and you would probably know by saying if that's iron, you know iron's a metal, so this would become ionic. And the last one, sulfur hexafluoride. Our first job, look at that first element. Is it a metal or a non-metal? And that'll tell us if we've got an ionic or a covalent molecular. So sulfur is right here, number 16. It is a non-metal, that little N, the lime green. So if it starts with a non-metal, then we know it is molecular. Okay. So major thing here to remember, molecular is two nonmetals and ionic is a metal and a nonmetal. So once we know that, you're literally just looking at the first element, and if it's a metal, then it's ionic. If it's not a metal, well, it's molecular. Properties of ionic versus molecular compounds. Well, molecular compounds on the right-hand side there, they are individual molecules randomly arranged. They have low melting points because they have weak bonds, and I already told you that on the other slide. Weak bonds happen there, so just gonna highlight that. So weak bonds, and they do not conduct electricity. So that's another thing to highlight, is that they do not conduct electricity. And they're randomly arranged. On the other side, these are crystal lattice. They have a high melting point because they have strong bonds, and they conduct electricity. Okay, so those are all sort of like, they're honestly the opposite. Ionic, very structured, has like a really, when it says crystal lattice shape, that basically means that it's, if you can see, this is a NaCl on the side. They're all really closely, perfectly in line, where this one is just sort of random. That's what the crystal lattice means. It's, I would say, nicely arranged. If it's gonna work. I don't like why it did that, I'm not sure. All right. So let's look a little bit into molecular compounds. It says, recall that a molecular compound forms between two non-metallic elements. In a molecular compound, electrons are shared between atoms, allowing each atom in the compound to achieve a full valence orbital. This results in a weak bond between each atom, and molecular compounds tend to be poor conductors of electricity because they do not form atoms. All right, so if you look at this molecular compound on the side, this is CH4. It's got one C and four H's, and each of those H's will give or share a electron with the carbon, right? And each carbon will share its electron with a hydrogen so that everyone becomes happy and has a full valence shell, okay? They do not conduct electricity because they don't form ions. So something to remember about electricity is that electricity is created by ions, and there's no ions here, so no electricity can be conducted. So this video, we can't watch it here. It's going to explain a little bit about naming molecular compounds. I will post that on the Google Classroom, but I'm also going to explain it to you right here. So this is the very first naming. We're going to do a bunch of different naming, and I'm going to split this into different videos just so you sort of do it in steps. But naming molecular compounds, it says the names of molecular binary compounds are made up of two different elements, and we follow these rules. So in order to write a compound, a molecular compound, our first step is to write the name of the first element listed in the chemical formula. Second is to change the ending of the name of the second element to IDE. And then the third one is use prefixes to indicate the number of each type of atom in the formula. Note that the prefix mono is only used if referring to the second element. All right, so all of that maybe doesn't make any sense to you right now, but we will do some examples and we'll refer back to this slide as we do these examples. Okay. So this table right here on the side is probably something that you would want to write down maybe on the back sheet of your periodic table or something, because this is something, or somewhere on it, it's going to be something to add to your sort of cheat sheet. You're going to need to know these prefixes. So if we're talking about one atom, it's mono, 2 atoms di, 3 atoms tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, nona is 9, and 10 is deca. All right. So let's go through how to name this. So this is CO2. So we want to find out, or we want to write the name for this. So to write the name for this, we need to write down, or our first step, I guess, if we look at these steps, is write the name of the first element. So our first element is C, and if you remember, C is carbon. So it's number 6 there in our periodic table. Right, so we will go and we will write down carbon. Next step, we need to write the element, the second element, and the second element is O. So that is going to be oxygen. Maybe you already know that one. And maybe you honestly might already know what CO2, what the actual name of it is. So this is a really good one to start with. I hope you know it's not carbon oxygen. So we're not done yet. The second step here says change the ending of the name of the second element to IDE. So whenever our elements are in a compound, we're going to take off, oops, it took too much, the ending, so it is ox, and we're going to add IDE. So that becomes carbon oxide, okay? But we're still not done. Our third step is to use the prefixes to indicate the number and type of each atom. So the number of each atom is indicated by the number behind it. So that 2 right here is telling us there's 2 oxygens. There's no number right below the C, so that's telling us that there's 1. Whenever we have, it's not 0 because we wouldn't write that element there. So if it's 1, then we just don't write 1. We only write it if it's 2 to 10. All right, so that means we have 1 carbon and 2 oxygens. So we need to write the prefixes, and I might not have left enough room here. This is oxide. So we need to write the prefix for 2. So this is, there's 2 oxygens, we write it as a prefix. So even though the number is behind O, we've got to write it the prefix before oxide. So for 2, our thing is di. So we're going to write dioxide. For carbon, there's only 1 there. And if you note at the very bottom of this, it says, note that the prefix mono is only used if referring to the second element. So we wouldn't write monocarbon. We would only write monocarbon if it was the second element in the formula. So we actually just leave it alone. So this symbol, or this element, I don't like that it's so far away, is carbon dioxide. And you might have already known that, CO2, carbon dioxide. But that's how we name it, okay? Let's try the second one. The second one is C again, starts with C. So that's carbon again. Cl, if you don't remember that one, you can go to the periodic table. Cl is number 17 here. It's chlorine. So I'm going to write chlorine here. I'm going to leave some space so I can put my prefix. Our second step in our list of steps to do is that we need to get rid of the ending. So the ending here is chlorine. We need to change it to chloride. So now that we've got carbon and chloride, now we just need to write this 4 in. We go over here, what's 4? Tetra. Get this sort of cut off. So this becomes carbon tetrachloride. You don't put any dashes or anything, and it should be sort of, there shouldn't really be a space there, but it's sometimes hard when you're writing it in. Remember, the carbon doesn't have any number below it, so we don't put mono in front, only if that becomes the second one, which is actually at the end here. Let's skip down to CO. C we know is carbon. O we know is oxygen, but when we put it in a compound, it becomes oxide. And then because there's no numbers on each of these, they would become mono. We don't put mono in the first one because there's never a mono there. We do have to put it on the second one, so this becomes carbon monoxide. So we actually we don't put double O, it's just monoxide. All right, so that's where we would use the mono when it's in the second element. One is the second one. The next one we would do is SiO2. So we got to look up what Si is. Remember, these are molecular, so they're all going to be on the right-hand side. They're gases or non-metals. Si is silicone. It's number 14. So we would go to write silicone. Why am I writing in highlighter again? Silicone. And then O2. Hopefully you know O2 is oxygen. Remember, when we put it in a compound, we get rid of the ending and it becomes oxide. Silicone and oxide, we just gotta tell what 2 is. 2, we've already done that one as di, so it becomes silicone dioxide. Sometimes people will put silicone oxide di or something like that, and they're on the right track, but these are prefixes, and if you remember anything from English, prefixes mean they come before the word, not after. All right. The last one here, because I already did the bottom one, is P2O3. So we want to do this one. We got to look up what P is and what O is. We already know what O is, and you might already know what P is, but we'll look that one up. P is right number 15, it's phosphorus, and O is number 8, that's oxygen. So we've got phosphorus, and oxygen, but it's the second one in here, so we write oxide. And then we've got to write prefixes for both of them. 2 for phosphorus, that's di, and 3 for oxygen, which is tri. Sorry, I'm not going back over here, but yeah, di is 2, and tri is 3. Okay, so that becomes diphosphorus trioxide. Okay. So these are the easiest ones to name, and this is sometimes why we start with this one. So that's great. We've gone from chemical formula to words. Now we want to go from words to chemical formula. So it says if you're given the name of the molecular compound, it's easy to determine the chemical formula because the prefixes tell us how many of each atom is present. For example, carbon difluoride is 1 carbon and 2 fluorines. So we would put CF2. All right, so let's try a couple practice ones here, and then you'll try some on your own. The first one here is dihydrogen monoxide. So when we're doing these, our first step is to figure out what our elements are. Right here we've got hydrogen and we've got oxide. Hopefully you are aware that hydrogen is H and oxygen or oxide is O. So we've got H's and O's. Dihydrogen, that means we have 2 of them. Monoxide means we have 1. So dihydrogen monoxide is actually water, H2O. That is our symbol for that. Oops. I was trying to highlight it. Perfect. Our second one here, nitrogen trihydride. So we first got to figure out what the symbol is for nitrogen. And it should be number 7 in the periodic table, I believe. Double check. So yeah, number 7. Periodic table. And then the other one is hydride. Hydride. So that one might be a little bit hard, but hydride is actually hydrogen, number 1. And just changing that ending. So we've got nitrogens and we got hydrogens. There's no number, there's no prefix in front of nitrogen, so it's just one of them. And tri, if we look over at our thing over here, tri means 3. So it's NH3. Our next one, dinitrogen tetrahydride. We've got nitrogen again and hydride again. They've just changed the prefixes. So nitrogen, now we have a di in it. Di means 2. So we put a 2 behind it. And then tetrahydride is 4 after the hydrogen. The fourth one here is dihydrogen monosulfide. So we notice that we've got hydrogen there, which is our H, and sulfide. If we're unsure about that one, remember when it's in a compound that we are changing that ending of it to be ide. So this is actually sulfur. Sulfide, we're getting rid of that UR and adding the IDE. Okay, so that's an S. It's mono, so there's none of them, or there's one of them. We don't have to put a number there. And then 2 hydrogens. So that becomes H2S. And then our last one here, phosphorus tetrahydride. Phosphorus we've already done before is P, and trihydride is our H. Phosphorus doesn't have any number or any prefix, so there's no number below it. Tri means 3. I've already got that one circled there. So that becomes 3. So we got pH3. All right. So that is all on how you would name molecular and write molecular formulas. I believe there's some for you to try out. Let me just double check. There should be some there for you to try on your assignment on topic 4. Yes, there's tons of them for you to try. So for this, for this part of this lesson, you're going to be able to do question one, just question one, but there's 30 different ones to try. So lots of practice for you. So try that out on your own. So try question number one on topic 4 assignment. All right, and that's where we're going to stop right now. That's lots of practice for you to do on that one, and we'll see. Let me know if you have any trouble with doing that. All right.